Okay, now coming to the most important part of the unit, Kirchhoff's laws and its application. But before we start with Kirchhoff's laws, the idea about some circuit terms should be clear. That is, what is meant by node, what is meant by branch, what is meant by loop, and what is a mesh. So to begin with, what is a node? Node is definitely a point with two or more elements have a common connection. So it's basically a connection point. If you look at the example given below, you can identify the different nodes here. There is a node connected between the source and the resistance. There is a node connected between the three resistors, and there are nodes on other parts of the circuit as well. So in this example, you can identify there are 6 nodes. So node is nothing but a connection between any two elements. Now coming to branch. Branch is nothing but a path. It's a single path. In the same example, all the branches are highlighted. A branch should have one element and there should be a node on both its ends. And the simple way to identify the branches are just identify how many different elements are there in the given example, and there will be those many branches. Like in this example, there are 6 resistors and 1 voltage source. So there are total 7 elements, and hence the number of branches in this given example is also 7. Now the next topic, what is meant by loop? So loop is nothing but a closed path. Closed, that means the starting node and the ending node are the same. So if you look at this example, how many loops can you identify? There is a loop starting from A to B, coming to E, then F, again back to A. On the other part, you have the second loop formed by B, C, D, E and B. But there exists one more loop, in fact that is the bigger loop, starting from A, going to B, then C, D, E, F, back to A. So the loops are any connection, any closed path. The only condition is the starting node and the ending node will have to be the same. So in this example, there are 3 loops. So what is the difference between the term loop and mesh? We often use these two words in the place of each other, but there is a basic difference between mesh and a loop. Mesh is always the term that we use to represent inner loops. That means if you say that this is a mesh, it cannot have any inner loops inside. So in this example, if you see, there are only 2 mesh, because the outside connection cannot be treated as a mesh because there are inside connections available. So in this example, how many meshes are there? There are only 2. Hope you understood the difference between loop and mesh. Examples will be given in the worksheet to identify the nodes, branches, meshes and loops. Okay, so now going into the main topic, Kirchhoff's laws. There are 2 Kirchhoff's laws. They are called Kirchhoff's current law and Kirchhoff's voltage law. The necessity of these laws and the importance are that they are used to solve complex circuits. Complex in the sense there are multiple elements either as resistors and voltage sources or current sources. So our idea about the series parallel analysis and Ohm's law will not be enough to solve these complicated networks. So as I told you, there are 2 laws, Kirchhoff's current law, commonly called as KCL, and Kirchhoff's voltage law called as KVL. Now let us see one by one. Kirchhoff's current law. From the name itself, it is a rule related to current. The statement is that the algebraic sum of the currents meeting at a junction is equal to 0. So this is a rule which we can use only at junctions. That is why it is otherwise called as junction rule also. So a simple example you can see here, a junction of a given network is highlighted here, and you can find there are 4 branches at the junction, and there are some currents identified also. So if you look at the directions of the current, A and B are entering the junction, D and C are leaving the junction. So according to the rule, IA plus IB, that is the total current entering the junction, should be equal to ID plus IC, that is the total current leaving the junction. In other words, no current should remain at the junction. If there is a current entering, it should leave by some other branch. Coming to Kirchhoff's voltage law, the statement is more or less the same. The difference is that it is a rule related to voltage. So the statement is, in any closed electrical circuit or mesh, the algebraic sum of all the voltages, that means including electromotive forces, that is the voltage of the sources, and voltage drops in resistors. So the sum of all the voltages is equal to 0. Since this rule is applicable only for a closed network, this is sometimes referred as the mesh rule or loop rule. So that means you can apply this Kirchhoff's voltage law to any closed network, and the application is that it can be used to find out some unknown voltages. Okay, let us try to write the Kirchhoff's voltage law equation for the given example. So there are 3 voltages. So the rule says that the algebraic sum of the 3 voltages equal to 0. So when we write the algebraic sum, it is important that we first identify what is the sign of each voltages. So theoretically, if you look at the first element, how do you identify the sign of the first voltage source? So the method says that as you move ahead, if you find that there is a rise in the potential, that means that voltage is positive. So here in the first element you can see that it increases from negative to positive. It's an increase, it's a rise. So the voltage of this first source is plus V1. Now as you move ahead, look at the second element, and here you find that it is first terminal is positive and the second terminal is negative. So you find here actually a fall in the voltage. A fall in the voltage is represented by a negative sign. So this is theoretical aspect. Now a shortcut is that as you move ahead inside a loop, look at each element and look at their second terminal, and the sign of that voltage will be same as the sign of the second terminal. So if you consider this example, look at the first element, and as you move ahead, what is the second terminal you identify? It is positive. So this voltage is plus V1. Coming to the second element, what is the second terminal you find? It is negative. So this is minus V2. For the third element, the second terminal you notice is positive. So this is plus V3. So that means the equation is plus V1 minus V2 plus V3 is equal to 0. So if you have some other elements other than voltage sources like resistors, we can include them also in the equation. The only difference is that their voltages will be represented by Ohm's law, that is I multiplied with R. An example will be seen in the next slide. One example is given here. You can see in the given example the question is find Vx, that is this voltage, and current Ix, that is the loop current. There are 3 elements. So applying the same rule that we found in the previous example, let us start from this end. So look at this voltage, it's 5 volt. What is the sign of 5 volt? Look at the second terminal, so it is plus 5 volt. Come to the second element, it's again another voltage source. The voltage is 7. The second terminal is positive, so again this is plus 7. Now look at the third element, it is a resistance. The voltage of that resistance is the unknown voltage that we need to find out. So we can write the equation in terms of this V itself. Look here, the value is unknown, it is represented as Vx, and the second terminal of Vx is negative. So this is represented as minus Vx. So that gives you the equation plus 5 plus 7 minus Vx is equal to 0. Or solving this will give you Vx is equal to 12 volt. So one answer is done, Vx is equal to 5 volt. Now since you know this voltage and you know the resistance and there is only a single current flowing through the network because it's all our series, Ix can be found by applying Ohm's law. I is equal to V over R. V is 12 and the resistance value is 100. So the calculation gives you an answer 0.12 ampere. More examples will be done in the class. The worksheets will be uploaded. Please take a printout of the worksheet and come prepared for the class.